finding the horizontal asymptote of a rational function. A rational function, again, is any function that has a polynomial in the numerator and a polynomial in the denominator. So I'm going to say that n is the degree of p of x. So the numerator is an nth degree polynomial. I'm going to have m is the degree of q of x. So q of x is an nth degree polynomial. We're going to talk about three different situations. Situation 1, n is smaller than m. For instance, let's take f of x equals x plus 1 over x squared minus 4. My numerator is a first degree polynomial. My denominator is a second degree polynomial. So this is a case where my top degree is smaller than my bottom. In this situation, every one of these graphs will always have a horizontal asymptote at y equals 0. I'm now going to take a look at the graph where y1 is going to be set equal to x squared plus 1 divided by the quantity x squared minus 4. I'm going to graph this in a standard window by hitting zoom standard number 6. Enter. Sorry, we had a little flicker in the lights there. If you'll take a look at this graph, notice on the left-hand side my y is getting closer and closer to 0, and on the right-hand side my y is getting closer and closer to 0. What I'd like to do is go ahead and turn off the axes so I'm not looking at everything all at one time. I'll do that by going to the Format button and turning my axis off. Now if you look at the graph, and I'll hit the Trace button, I'm going to get over at around -5 on the graph. Notice the y value as I go to the left, it's getting closer and closer to 0. If I move over my x value to +5, now I'm on the right hand side. Notice it starts off very high, oops, but then it keeps going down, 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 and what I am approaching is a y value of 0. So that is called a horizontal asymptote. Here is another rational function. I notice that the degree in my numerator is smaller, being a first degree, than the degree in the denominator, which is a third degree. Because the numerator has a higher degree, I will have a horizontal asymptote at y equals 0 every time the numerator is larger. We're now going to look at the second scenario. This is when the degree of my polynomial in the numerator is the same as the degree of my polynomial in the denominator. Notice, my numerator is a second degree polynomial. My denominator is also a second degree polynomial. In this scenario, what we're going to look at is the lead power function's constant in the numerator, and we're going to look at the lead power function's constant in the denominator. In this case, it's a 1. That tells me that I will have a horizontal asymptote at y equals 2 over 1, or simply at y equals 2. Okay, I'm going to go ahead and graph this rational function. 2x squared minus 3 quantity divided by the quantity x squared plus 1. And what I had predicted was when I hit graph, oh, let me put my axis back on from last time, that I'm expecting a horizontal asymptote at y equals 2. Notice, as I go to the left, I'm going to push trace. As I go to the left, my y value is getting larger, larger, larger. 1.7, 1.9, 1.94. It's actually going to get closer and closer to 2. As I go to the right, same thing's going to happen. I may have some stuff going on in the middle, but as I go far enough out to the right, the y value is going to get closer and closer to the y value of 2. Case 3, when the degree of my numerator is higher than the degree of the denominator. For instance, in this case, I have a third degree polynomial in the top, and in the bottom I have a second degree. In this scenario, we have no horizontal asymptote. That's the easiest one, nothing to find.